We have Jennifer Christiansen from Scientific American. She's the graphics editor there. And she's going to be discussing how to develop scientific data visualizations for the non-specialist audience. So this sort of dovetails well into Nicoletta's and Alyssa's discussion. So, Jennifer.
Great, thanks so much. Let's see, I'm going to try sharing my screen here. And here we go. Can I have audio confirmation that you can hear me and see the slide?
Yes.
Yep.
Excellent, thanks so much. Yeah, so thanks for including me this morning, and thanks to the folks listening in and watching for carving out some time to look at your screen some more today. It's really interesting to hear what other people have to say that are coming at things from slightly different angles and with slightly different purposes, but it all really kind of everything I've been hearing so far resonates a lot with the kinds of things that I think about and work with and do on a daily basis as well. So we started out this morning talking a little bit more about conceptual art in the service of science with Michael's talk about kind of concept pieces and Kelly's conversations about or discussion about developing covers. And then we just heard some more about creating schematics and kind of what you think of when you think maybe of schematic diagrams and graphics. I'm going to be speaking a little bit more solidly to data visualizations today. So we're going to take things into a very kind of quantitative realm now. So let's start here. What are data visualizations? Let's see, there we go. I'm gonna modify my screen a little bit here. There we go. So data visualization is essentially information that's chiefly numerical made visible, but that's a pretty broad definition. Whoops. There we go. Encompassing everything from bar charts to even dinosaur reconstructions, which are illustrations rooted in scientific measurements of things like bone length. In general, however, folks usually think of data visualization as abstract representations of data rather than figurative illustrations, and that's what I'll be speaking to this morning. Now, for sure, data visualization is strongly rooted in content. That's the information that you're visualizing. But this morning, I'd like to encourage you to take a step back and also think about the ultimate context. For whom and why? The content is often fairly straightforward, especially if you're a scientist working with the data that you've collected. It's the information that you're setting out to visualize, from time series to interconnections, category comparisons, and beyond. The data set itself influences the form of your visualization. But I don't think that people think about context enough. The intended audience and purpose should also be considered. Form follows function. I think it's more intuitive when people think of text. I think many people understand that there are different writing styles that are used for advertising, narrative nonfiction books, PR, scientific journals, and newspapers. You'll see different styles of writing in each of those different categories. So this talk is divided into two sections. I'll provide some best practice tips and resources that relate to content, and then I'll move on to discussing the idea of context, with the goal of getting you to think critically about how you can present your data to the public and engage audiences beyond your peer group. I should note that I'll be focusing on data visualizations that are developed to communicate results to an audience, not visualizations that are used as tools for analysis. And rather than focus on the tools and the technical details related to building those data visualizations from scratch, I'll present strategies that should be helpful for a wide range of researchers, regardless of your existing skill set. I'm operating under the assumption that some of you might rely on Excel for chart output, while others might develop custom code for novel visualization forms. So for that reason, I'll focus on higher level strategies that should apply to folks across the board, regardless of the tools that you use. Then I'll use a few before and after examples from Scientific American to provide you with concrete strategies for presenting your data to lay audiences, ranging from just kind of simple edits to moderate reworks to really kind of more complex and bespoke solutions. Shortly, I'll share some references like books and blog posts that include some design best practices and tips. But first, I'd like to present one case study. So this example is courtesy of Robert Simon. He's a data visualization engineer with Planet Labs. He wrote a blog post for the Scientific American website using an example rooted in sea surface temperature. You can read the full post at the URL shown here. I'll also have all of these URLs on my last slide, so you can have a moment to catch them all if they buzz by too quickly here. So despite being relatively simple, this is just one variable changing over time. The data is a little bit difficult to read in this original chart by NASA's Scientific Visualization Studio. Now, part of that might have to do with kind of their built-in defaults. So this isn't necessarily a critique of a particular studio. It's just using it as an example to show you how things can be fine-tuned and pushed further. So Robert improved on it by creating visual hierarchy with subtle changes in typography, color, and arrangement. Here's the redesigned chart. As he wrote in that blog post, quote, "A visual hierarchy brings the most important elements of a graphic into the foreground and pushes less important elements into the background," end quote. So what did Robert change in order to shift attention from chart architecture to the data? Well, he removed the frame around the graph entirely. It flattens the graphic and kind of makes the page kind of at the same level of importance, kind of flattens things out, as I mentioned. So he also adjusted the red, neutral, and blue colors so that they'd have equal visual weight. In the original, that white central zone is dominant and kind of glows, and it really pops out. But in the revised version, the red and the blue tones don't fade into the background, and it's a little easier to read this as a continuous line as opposed to having your focus drawn to that central white band. He removed intermediate tick marks and some of the labels, which made the remaining labels easier to read and reduced kind of the visual noise. Visual noise, you can think of it as clutter that doesn't really help you see the signal, but just might distract from that signal. He shifted some of the labels off to the side of the chart entirely. Now you'll notice that these were all pretty subtle design tweaks. The chart form remained intact because a line chart is a great way to show change over time. His adjustments are all related to clarity and improved legibility. There are a lot of great guides to help you make chart type choices. Like I indicated in that last one, a line chart is a great way to show change over time, but it's not necessarily the best way to show kind of change differences in buckets from like discrete categories. That might be a bar chart, might be your best choice. But there's lots of choosers out there that can help you kind of make these decisions. Here's one from the journalists at the Financial Times. At the top of each column here, there's a different data relationship or goal that's described, like the one here that I highlight speaks of the idea of flow. Below that description, there are a series of recommended chart types that they suggest that you use. And this is kind of just to get your, kind of help with the initial brainstorming stage. This isn't necessarily hard and fast rules. If you tend to stick to very kind of classic chart forms like line charts, bar charts, and the like, and if Excel is your primary charting tool, this book by Stephanie Evergreen is a great guide for getting you to think clearly about the point that you hope to make with your chart. And these two titles from Alberto Cairo are particularly useful for journalists, but chapters on topics like perception science makes them useful to a much wider audience. The functional art also gets into kind of schematic graphics as well, but the truthful arts and a lot of the functional art are focused on data visualization. But I kind of often recommend the functional art as your general kind of all-purpose. You want to get going to understand some fundamentals across all types of graphics. Now, these two books go further into the types of design decisions that Robert Simon exhibited with the sea surface chart makeover that I shared earlier, that temperature chart, excuse me. Both of these start with the basics. The fundamentals of data visualization, I think, is particularly relevant for scientists. Earlier, Alyssa mentioned that sometimes the language of artists and scientists kind of can provide a block, but Klaus, who wrote the fundamentals of data visualization, is a research scientist first, and so the language he uses and the examples he presents might feel more familiar to another research scientist. Andy Kirk's book and website are incredibly deep and wide resources for all things data viz. If you don't know where to start, you can go to his site and kind of figure out what you need from there. And here's one of my favorite articles on color. It was just published a week or two ago. It's by Lisa Charlotte Rost. It walks you through common color mistakes and how to avoid them. It's a really kind of conversational and easy to understand and very kind of clear post that I think has a really wide relevance. Okay, let's move on to specific strategies for sharing your data with non-specialist audiences. I'll start with an example that simply reframes an existing chart. So perhaps you have a data visualization that was developed for a peer-reviewed article, and you're hoping to make it either more accessible to a broader audience or a quicker read for your peers in something like a poster presentation. So this chart was provided as the reference material for an article on the rings of Saturn. The top chart shows how a star dimmed in a spotty manner over time. It's one of the early lines of evidence that suggested something irregular might be passing quickly in front of a distant star, dimming its apparent brightness as viewed from Earth. Other graphics in the article would get into the research that followed, but first we wanted to present the weird data that captured the scientists' attention. So we presented the central part of the chart pretty much as is. But as a welcoming gesture to the non-specialist reader, we flagged the take-home message clearly with a title to signal that this data presented scientists with an odd pattern, kind of a riddle to solve. Then we shook the jargon out of the labels and added 2 annotations or notes tied directly to the chart patterns, as seen in the tan circles here. That would help explain clearly what people are looking at without requiring them to kind of bounce back and forth between like a really long caption and the image. Here's a side-by-side look. Now, I'm not trying to suggest that the bottom version should replace the top version in all cases. You'll note that we removed some pretty critical information, such as actual flux values, which are boxed here in red, and specificity with regards to time, which is boxed in orange. But because that top version exists in the primary literature, I have the freedom of stripping out some of that content here, knowing that a source citation will lead a reader that needs to know more to the more complete story. Now, many scientists use some really sophisticated and complex visualization strategies when analyzing their data. Kelly noted a few of those that actually then end up turning into covers with really kind of rich and engaging forms. And often those visualizations can cross over into being really engaging and effective communication tools as well. Here's one example. It's the sort of visualization form that takes a lot of effort to figure out how to read, quite frankly. But the payoff is worth it, because once you learn how to read it, you're kind of rewarded with the ability to discover all sorts of interesting patterns within the image. So here's the version as it ran in our magazine. So this Scientific American rework clearly includes an aesthetic shift. There's been a change in color palettes and typography, for example. Data designer Jan Willem Tulp made a lot of subtle design changes, but the core of it is pretty darn faithful to the original. The critical change here lies in the addition of some playful insect illustrations that provide a more just a bit more context for an otherwise really abstract set of charts. And then along with the title, those illustrations sort of help signal that these charts represent data that is related to migrating insects. There's a fine line sometimes between adding kind of illustrative details like this and kind of tipping over into what Edward Tufte has kind of coined the term of as being chart junk. But I think there's a really kind of a lovely use for them and kind of helping engage a reader who might otherwise be put off by kind of the abstract nature of things. And to help people kind of remember, this in their mind's eye when they're thinking back on what they had read in the past. We also added a clear how to read this graphic panel. It's kind of a welcoming gesture. It's a clear starting point for the reader. If you turn to the page and you don't know what you're looking at and you're trying to figure out where to start, we kind of clearly flag that as a start here. We're going to walk you through how to read this graphic in kind of a very kind of a casual and kind of narrative way, much in the way that you might talk a friend through reading it. And that kind of sets up the reader with the tools to then dive into the actual graphic itself. So here are those two versions side by side. Now, sometimes a bit more work is involved in customizing an existing data visualization for a broader audience. Often information needs to be added to help the reader more fully understand what they're looking at, or the information needs to be kind of reorganized for a clearer look at the broader story being told. Here's another chart that shows an apparent change in brightness of a star as viewed from Earth. The source of this particular light pattern is Boyajian's star, named in honor of astrophysicist Tabitha Boyajian. Here's the final magazine graphics box that was rooted in that chart. The right-hand side is similar to some of the examples I showed earlier. Jargon has been replaced with plain descriptive language, and a few on-art labels point out the critical details. The key addition here is the diagram on the left. With this schematic, we've added some background information for the non-specialist reader, specifically an indication of why the apparent brightness of stars often changes, and what that sort of pattern usually looks like. Armed with that information, the reader can then see why the pattern on the right is unusual. Again, here's the original at the top and the magazine version on the bottom. Finally, custom solutions are an option. We heard about some of those from Niki and Alyssa earlier. So sometimes a visual isn't necessary for analytics purposes, but it's a handy way to communicate findings to broader audiences. Often that can cost time and money, but not always a lot. There's a kind of a scale there. For example, here's a table from a paper on conflicts of interest in publishing on cardiovascular risk and specific medications. So this table is perfectly suited for its purpose, a research paper in the primary literature. However, a non-specialist reader might get lost, kind of unsure of the take-home message. Which numbers should they really be focusing on here and compared to what? So in this case, a simple visualization rooted in a small portion of that table can help make the primary point clear. Here's the visual we ran in the magazine. Now here we show authors of scientific papers that declared a conflict of interest with a particular class of drugs in red. Authors with no financial conflict of interest are shown in blue. As it turns out, those same authors, the ones in red here with a conflict of interest, were more likely to publish favorable conclusions related to that class of drugs. You can see that in the top row here, where most of those published favorable accounts have a conflict of interest and are shown in red. Here are the two items side by side. Now, this chart wasn't complicated to build, nor frankly is it as rich as the original table, which contains more information. But it does provide an engaging entry point for an audience that might not be willing to wade through a table or really have the background to understand what they're looking at in that table. Not all custom projects are so straightforward. In some cases, like this one, you may have a clearly identified and discrete data set, and you may have developed some serviceable visualizations for publication. But it may be worthwhile to hire a data visualizer to take things to the next level with a different audience in mind. This study found that nurses interact with the widest variety and largest number of individuals across the hospital. Now that's information that could provide useful in developing strategies to contain disease outbreaks within hospitals. The research scientists used visualization as a tool for analysis and published the results in this form. If the goal is to then communicate those results to a general audience in an aesthetically pleasing and engaging manner, you can consider hiring a professional. In this case, I obtained the data from scientists and asked data designer Jan Willem Tulp to visualize that information for a lay audience. Here, each line represents a face-to-face interaction among individuals in a hospital as detected by RFID tags. Each gray node shows an individual's total number of interactions. The colorized nodes show the number of interactions with a specific group. So as an art director, I hire other artists to develop solutions like this all of the time. And that option is also open to research scientists, assuming you build in the budget to do so. So how do you proceed? Well, first of all, build in time for many iterations, as Alyssa noted. Even straightforward text-based modifications can take some time. And many of the examples I've shown were not the first attempt at that solution. For example, for a piece on reconstructing the Sierra Nevada mountain range based on ancient rainfall data, we started with the data from the chart on the left. Data designer Tiffany Ferrant Gonzalez broke things down into separate panels so that we could walk people through the different time periods one at a time. But this was not the first attempt at a solution. Here are some of the steps along the way in which Tiffany explored different ways of displaying the same data. Now, the decision to show each time period as its own chart was made pretty early on, so we broke it down into 3 pretty quickly, but lots of subtle variations were explored before we honed in on the final version. Perhaps the best piece of advice I can give you is to simply look at your material with fresh eyes. Let go of the jargon and think about how you can use plain, descriptive language to approximate the message for an audience that doesn't speak your jargonese. This goes for visual jargon as well. Does your field rely on a certain chart form because they're simply a part of the lexicon? So rather than just kind of flock to that default, think about the story that you have to tell with your data and how you can best feature that story. Look at your material through the eyes of your intended audience. For example, here's a chart that appeared in a university research magazine. It's the same version of the chart that appeared in the peer-reviewed journal, but the audiences are not the same. The university went to the trouble of using a professional photographer to feature the scientists in action, but they didn't give the graphic that same level of consideration. And that does a disservice to the scientists, their work, and your audience. Here's a closer look. If you hope to engage the public, it's important to look at the figure with fresh eyes. Why are you including it in your article, and how can you help your readers interpret it? At its simplest, this can simply mean kind of translating the caption at the bottom and creating smaller notes tied directly into the graphic with leader lines. And shaking the jargon out of the labels. You simply can't present the public with axis labels such as TPS bracket 1. But I'd advocate making the time to take things to the next level. Set up a title and an introductory text block, then deconstruct the graphic and walk people through the results. Here in this mock-up, I simply separated out the samples used to construct the model and the samples used to test the model, which was one of the points they were making with the original. The end goal is to provide an engaging, clear, and informative graphic, and you don't need to like water anything down or simplify in your efforts to clarify. Just approach the source material with a fresh eye and think about how you can best guide a non-specialist reader through the content. So always remember to ask for whom and why, and allow those answers to inform the shape and details of your final visualizations. So here in the blue bar is a link to a Google Sheet that I maintain that includes more resources, including the names and information about the books and posts that I had earlier. But those book and article links are also in teal below on this deck. All right, let's see if I can stop sharing my screen and hand things back over.